arrays and data structures in Python. We continue our discussions on Numpy arrays. Indexing. To begin, you write import Numpy as np. Consider this array x, np.arrange. With arrange function, you create this array from 2 to 15 in step of 3. So you got this one-dimensional array 2, 5, 8, 11, 14. Now indexing. We know that we count numbers, count elements in an array or list from 0. From left to right you go. This is 0, then 1, 2, 3, 4. So if you write x, within square bracket you write 0, then it will give you the 0th element. If you write x2, that means it will give you the element number 2 at the index number 2. That means this 0, 1, 2. So element 8. Now if you write x minus 1, what it will give? It will give you the last element in this array. So you know from left to right, if you count from 0, 1, 2, 3, 4, also you can count from right to left. That means it will be minus 1, it will be minus 2, minus 3, minus 4, minus 5. Why this way? Because you can think this array as a strip which you can fold to make a ring like this. So the 14 will come here over here before 2, and on the number line before 0 you have minus 1, then minus 2, and so on. So in this philosophy you index from the right to left in a negative numbers with. Okay, so you write x minus 1 is 14, then if you write x minus 2 it would be 11, and so on. Slicing. You have this array and you take a slice of this array. So if you write this way, 1 colon 5 colon 2 inside these square brackets, that means 1 is the start, 5 is the end, and 2 is the step. Of course it won't touch 5. So if you write the 1 means this is the index number 1, this is the 5, and then step size 2, that means you go over here 11, and of course you cannot go beyond that because it is the last. So also if you would write np.slice, that means you would use the method slice, and inside that you write 1, 5, 2, you rename it as say s, and then you put this inside x, also you would get the same result. But of course to me this is smarter, so you can adopt any of the methods. Okay, so you have this array again for reference. Now you write x3 colon, that means it will begin from 3. The endpoint is not mentioned, is blank, so that means it will go up until the end. And the step size is also not mentioned, that means automatically the step size is 1. That means you will start from 3, 0, 1, 2, 3. So 3 onwards, everything. So until the last. So it will give you 11, 14. If you write colon 4, that means it will begin from the beginning, that means 0th element, and go up to 4. 4 means it won't touch 4. So the thing is, you will start from here 0, 1, 2, 3. So it will slice out these elements 2, 5, 8, 11. If you write colon 2, that means to begin with you have mentioned nothing, so it will start from 0th element, end until the end, it go until the end, but the step size is 2. So that means it will start from here 2, then step size is 2 means 2, then 8, then 14. Okay, if you write 2 colon, that means you begin from the index number 2, go until the end, and step size is nothing given, so step size is 1 by default. So it will give you 8, and then 11, and then 14. If you write colon minus 1, that is interesting because you start from the beginning, end at the end point, but the step size is minus 1. That means you go in this direction. -1 means you reverse. That means from here, see, begin from 0 0 here, 0th element, say 2. If you go in the reverse in the step size -1, that means you go in this direction. In this direction means if you fold this as a ribbon like a ring, then you actually start from here 14. So that means you will get back the reversed array. So the array was 2, 5, 8, 11, 14. You try to see on how it comes. The number system is like this: 0, 1, 2, 3, 4, and then -1, -2, -3, -4, and so on. So you will get the reversed array. So this is, you remember this, x colon colon -1. This is a method. This is a way how you can quickly reverse a array. If you write colon colon -2, that means since the reverse is still the reverse direction, but this jump will be 2. So that means you come from 14, then go over to 8, and then go over to 2. So this is the way you slice an array. It is one-dimensional array. But now you say this is a two-dimensional array. And in the same way, in the two-dimensional array, it is written in a form of, looks like a matrix. It's a 2D array, and this is 0, 1, 2. This is the first row, second row, third row, fourth row. So I mean, this is 0th row, first row, second row, third row. So this 0th row or the first row, whatever. So this is the first 0th element, then the first element, second element, third element. So the slicing will be done accordingly. If you write 2 colon, that means you start from the index number 2. This is index, this row is index number 0. This next row is index number 1. This next row is index number 2. 2 colon means it will go until the end. So you get back these 2 rows, 6, 7, 8, 9, 10, 11. If you write colon 3, that means you begin from the beginning and end up to 3. That means 0th row, first row, second row. It won't touch 3. So you get the first 3 rows. If you write colon colon 2, that means it will start from the beginning, end at the end, and jump will be 2. So you get back 0, 1, 2, and you jump 2. That means, I mean, step size is 2. So you jump this and you come to here, 0th element and the second element, 6, 7, 8. Okay, so you get this. Okay, now if you write x only colon, that means you start from the beginning, end at the end, and the step size is not mentioned, that is automatically 1. So that means you get back the entire array again. So either you write x or you write x inside 1 colon, 2 colon, doesn't matter. You get back the entire array. But now this is how you sliced rows. Now you want to slice one column out of it. So the rows are like indexed like colon colon colon. Similarly, if you inside this, if you write something, this one colon, it can be 1 colon, it can be 2 colons, doesn't matter, but you put a comma. That means this part will be row part, and after comma you could also write in this same way, and this next part will be the second part will be for the column. So if you write here colon, that means you consider all the rows, this, but you write a comma and put a comma and then you write 0. That means you are trying to extract the 0th column. So this is for the column. So this after comma, this index will be for colons. So this is the 0, 4, 8. That means it is the first column you sliced. Okay. Now if you write colon comma 1 is to colon 3, that means all the rows here, then comma. For the column part, you begin from 1 and go to 2, and then you don't touch 3. Okay, so you get back 1, 5, 9, this column, and 2, 6, 9, and 10, next column. Okay, so this was your entire array, and the red numbers you have extracted out of the entire array. So this is this. If you would write 1 is to 3, 1 colon 3 comma 1 colon 3, that means for the row part, you take 1 to, you go 1 from 1 to 3, don't touch 3, that means 1, 2 you go, and for the column part also you go 1, 2, 3. So you get back 5, 6, 9, 10, 5, 6, 9, 10. How? You can see from the entire array. So this portion you chunk out, and this is this. So in this way you can slice array, slice rows and columns, and you can take out the certain portion that you want. In the same method you can apply for even higher dimensional arrays. So array of order 3, 4, 5, 6, it doesn't matter. You follow this same prescription. Okay. And also if you write, say, in the array X, you write inside, you put a logical statement, that also it takes. So if you write X comma greater than 3, that means it will take all the elements which are greater than 3 only. But you have not said, specifically mentioned, in which from which you extract the elements from the rows or columns. So it has actually flattened out. It took all the elements and discarded the elements which are less than 3 or equal to 3. You have the result is the array which is actually flattened. But you got the two-dimensional arrays. Now you get back a flattened one-dimensional array. So of course you can use this function flatten. This function, so x dot flatten, and you don't write it here anything. You can write something. You can write take help. So the array is this 0, 1, 2, 3. It is flattened out array. You can put a reference here. 0. 0 means it will go along the rows. So it will go 0, 1, 2, 3. Then next row 4, 5, 6, 7, and the next row 8, 9, 10, 11. If you would write x dot flatten 1, this would give 0, 3, 6, 9. This is the first column. If you go and check with your array, and this is 1, 4, 7, 10. This is the next column, and then 2, 5, 8, 11 next column. Arithmetic operations. Look at this array X and this array Y. Two arrays I show you on two one-dimensional arrays. You can now manipulate this, take these two arrays and do some arithmetic, like numbers, like for a scalar or numbers you do. If you write x plus 2, it will give you this. What it means? It means actually it will sum the elements, corresponding elements, element wise. 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10, etc. If you write x minus y, it will of course write x 1 minus 5 minus 4, 2 minus 6 minus 4, and so on. If you write x into y, x star y, that means it will write 5 into 1, 2, 6 into 2, and so on. See this. If you write x by y, it will divide 1 by 5, 2 by 6, 3 by 7, and so on. If you write x star star y, it will actually have power. So 1 to the power 5 is 1, 2 to the power 6 is 64, and so on. That means you can manipulate, you can take two arrays, Numpy arrays, and you can do as like a scalar algebra. You can do all these arithmetic operations. Okay, so this is fantastic. So x, suppose, is this array, today array 1, 2, 3, 4, 5, 6, and now you have taken another array which is one-dimensional array. So the shapes of the two arrays are different. Now if you write x plus y, what it will do? It is so clever that it will actually fit this array, and it will actually add this 1D array with each element, because this is 1D array of the same size. This is 1, 2, 3 elements. This is 1, 2, 3 elements. So it will actually fit with this. Then it will fit with this. So 10 plus 11, 1 is 11. 11 plus 2 is 13. 12 plus 3 is 15. Then 10 plus 4 is 14, and so on. If you write x plus 2, now x is a 2D array and 2 is a just scalar. So in this case, 2 will be added with each element. See, 2 plus 1, 3, 2 plus 2, 4, 2 plus 3, 5, 2 plus 4, 6, and so on. If you write x is a Numpy array, and this is not an array, this is a list. So the array will dominate, the nature of array will dominate. So what it will do, like the first example, it will add these 2, 3, 4 corresponding elements of the first row and then the second row. So it will write 3, 5, 7, 6, 8, 10. Array manipulation. Suppose you have this array 1, 2, 3, 4, 5, 6. You can write x dot t, capital T. That means it will transpose the array. So the transposed array is this. So it's like a matrix transpose. Okay, so rows will be columns and columns will be rows. You could write this with transpose function also. You get the same result. Functions over arrays. Well, suppose you have created this array 0 to 1 with a range function in Numpy. A range will create from 0. It will go until just before 1 and the step size is 0.1. So you will create the array 0 to 0.9. Well, now you use this function sine function. Sine where from you take? You take from Numpy package. So like the math modules in basic Python, you have the mathematical library, you have the mathematical functions in Numpy. So you call by np.sine. In the bracket you write x. But remember, x is not a single data, single point. Like any function you have used so far, you have in the argument you write a single number, say sine theta, sine 45 degree, or some sine, say pi by 4 or something. So whatever you write a single data point. But here x is an array, you have all the data points. So what it will do is that it will create an array where sine function will be applied on the each element. So sine of 0, sine of 0.1, sine of 0.2, it will give this array. So this is fantastic. So you have now created an array from a function where the function will apply on each element of the argument, right? So this is called vectorization. So the function here, sine function from Numpy, in fact all the mathematical functions are vectorized. Vectorized means the argument, inside the argument you can put an array or a list or whatever, where it will apply on all the elements. Okay, but now suppose you have created a list with range function 1 to 5. So of course x will be 1, 2, 3, 4, and you have a square root function. This is also a vectorized function from Numpy. Any function, any mathematical function in Numpy is vectorized. So you put inside as x is no longer a Numpy array but a list. You see the good behavior, you see the vectorization, you see the result. It will happen. But suppose you have created this x array and you use the sine function from the math module. So from math you import sine. Now you write sine over sine, in bracket you write the array. What it will happen? It will give you the error message. It will give you the error message because read the last line. Arrays can be converted to Python scalars, only size 1 arrays. So that means the size 1 means inside it is expecting a scalar, is a single number, but instead you have given a lot of numbers. So it can do it. So you have to understand the difference of sine function. Often you use sine function, sometimes you take from math, sometimes you can take from Numpy, but you have to understand the difference. In math, any mathematical function is not vectorized. In Numpy, all the mathematical functions are automatically vectorized. But suppose you write x equal to range 1 to 5. This is a range you created or list you created, and you define this function saying def fx colon return x square. That means fx is actually x square. Now if you write this, of course it will give you the error message because the function is not vectorized function like the sine function in the math module. Okay, but it is not vectorized. Okay, so you have the method to vectorize actually. So this is the vectorize method function from Numpy. So if you write this function that you have created inside this argument, and you can put any name. I have kept the same name f. You can check what is this f now. After vectorization, it will tell you numpy.vectorize. So this is a different class. So now you have the X list 1, 2, 3, 4. X can be list or Numpy array, doesn't matter. If you write fx, well, you have got the array. Now because your f is now vectorized like the functions in Numpy array. This is the end of part.